Hey guys, welcome back. As promised, we're going to talk about this next stuff now. So this is what I mean when I say the points we need to graph these things. Like we're going to try and do these with t-charts most of the time. We're going to have x's on the left, we're going to have f of x's on the right. And here's the thing. If the parabola looks like this, then using 0, -1, like using these 4 points would work pretty well, these 5 points, because like you would get the shape of the parabola in them. If I graph this point, this point, this one, and this one, I could see pretty clearly the parabola looks like this. But if the parabola looked like this, and I use those same x's, like this x, this one, and this one, I'd get like this point, and this point, and this point, and a couple that were way up there, and I'd be like, well, I don't actually know what I want to get this part of the parabola to get the shape of it. Like I need the vertex and a couple points on the left and right in order to make a meaningful graph. So how do we get those points? And here's what we do. Given something in vertex form, what's your vertex form? You like figure out what the vertex is going to be. And remember, we said the vertex was h comma k. So given this, and referring back to this form, it's x minus h, x minus 2, so h must be 2. And it says ax minus h squared plus k, and it says x minus 2 squared plus 3. So my vertex is 2 comma 3. So I know that this point is on the parabola, which is great, but I don't know if it like goes up like this a u or down like that a u. So here's what you do. When you're making your t-chart, instead of using these 5 points like I did before, I did right down here. Instead of using these 5, instead of using -2, -1, 0, 1, 2 every time, put the vertex, the x-coordinate of the vertex in the middle. So I'm going to put a 2 right here in the middle. I chose 2 because it's the same as h. And then you go 2 units down and 2 units up for the most part. Sometimes we might do more than 2, but for now we're going to think about it as 2 up and 2 down. And now when we plug these in, we're going to get good numbers. I know if I plug a 2 in, I get 3 because that was here. But let's just see, 2 minus 2 squared is 0 plus 3. Okay, that works. Let's try 0. 0 minus 2 is -2. -2 squared is +2, but +4. 4 plus 3 is 7. 1 minus 2 squared is -1 squared is +1 plus 3 is 4. And I know, and y'all will see this pretty soon, that if these are evenly spaced, this is going to be 4 and 7 again also. So that's how parabolas work. But you can plug these in 3 and 4 into here, and you'll get 4 and 7, I promise. Now I have 5 points and I can graph. So I got 0, 7, 1, 4, 3, 4, 4, 7. Now I kind of have my shape, right? This thing kind of looks like a parabola now. All right, imagine I actually hit those points. Like I said, if I wasn't using a drawing tablet, I would have a much easier time with this. So, parabola graph, it's like super pointy. Okay. So that's what I mean when I say the faster we get the points we need. You've got to have the vertex in the middle, or else it isn't going to work. So two terms you should know: the axis of symmetry. The axis of symmetry is this: a vertical line that goes through the vertex, basically. This is a vertical line that passes through the vertex of a parabola. I'll be asking you for the equations of these axes of symmetry, and those have to always look like x equals a number. For the vertical line, the equation of the vertical line is x equals a number. And if you know what h and k are, the equations of these things are always going to be x equals h. But it's always going to be x equal a number, no matter what. Yeah, that's what the axis of symmetry is. I sometimes abbreviate it AOS. And the intercepts, there are two possibilities. It can be y-intercepts. This is where where x equals 0. And on a graph, it's like where it crosses the x-axis. Sorry, the graph crosses the y-axis. And every parabola has exactly one y-intercept. And then x-intercepts, which tend to be a little more important, a little more difficult to find. You get them by setting y equal to 0 and finding x. And these are where the graph crosses the x-axis. Now, for any given parabola, could have 0 x-intercepts, could have it's always one of these. And for a parabola could have either 0, 1, or 2 of these. And it just depends on the parabola. So you can think about vertically shifting this thing up, and you can see that there's clearly two y-intercepts here, or there's two x-intercepts here. If you shift it up just right, you could have just one if this point was right on the axis here. And if you shift it up even farther, then there could be no x-intercepts. But there's always one y-intercept. True story. Okay. So graph the quadratic function. Okay. So basically what we're going to do is we're going to be like, we want to find the vertex and then graph 2 points on either side of it, and then sketch in the rest of the parabola. That's how we're going to graph these things, at least for now. So given this thing, HK, H is in here, H is going to be -2, and K is going to be +5. So that's true because remember this was X minus H, this is X plus 2. So the number I subtract to get +2 is -2. So that goes in the middle of my chart, and I go down 2, I go up 2, and I'm going to graph these numbers. I got to figure out what I want my y's to be. So let's see. If I put a -2 in here, I get 0 squared plus 5. That's 5. I knew that was 5 anyway because the vertex. If I put -3 in there, let's do that one. Actually, I have the -4 first. So -4 plus 2 is -2. -2 squared is 4. -2 times 4 is -8. -8 plus 5 is -3. Okay. If I put a -3 in there, -3 plus 2 is -1. -1 squared is +1. -2 times +1 is -2 plus 5 is +3. These are going to be the same as those two. Again, you're welcome to calculate these if you want, but I promise they're going to be the same. So -2, 5, -4, -3, -3, +3, -1, 3, and 0, -3. So you can see this is like an upside down parabola. It looks like this. That makes sense. Like this is the flip, the vertical flip, the vertical reflection. The -2 means that you reflect it. The 2 means that it's like a little skinnier than it would be normally. And these numbers are the shifts left and up, the translations. So it's kind of how we can graph these things without doing a ton of work. A little bit of arithmetic in there. And now I'll answer this question. Maybe we'll do this kind of class or something. I don't want to make these videos too long. So graph this thing, label the vertex, the axis of symmetry, and find all the intercepts. This is like, I'm going to give you guys all the possible. This is like essentially all the questions I could ask you about a particular parabola. graph it, label a vertex, find the axis of symmetry, and find all the intercepts. And then these two questions. So we'll do these first. So we'll graph it. Actually, it's not quite in vertex form yet. So let's go ahead and make it. I got to move the 6 over. So I get y equals 2x plus 1 squared minus 6. Shows that my vertex is -1, -6. So let's do -1 in the middle, 2, -3, 0, 1. I know that -1 gives me -6 because that's the vertex. I'll put a 0 in first. That's a pretty easy number. 0 plus 1 is 1. Squared is 1 times 2 is 2 minus 6 is -4. And then I put a 1 in. That's 2 squared is 4. Times 2 is 8 minus 6 is 2. We'll match those two. -1, -6. 0, -4. 1, 2. -2, -4, -3, 2. So it should look something like this. So I graphed it, I labeled the vertex. The axis of symmetry is the vertical line that goes through the vertex. We said that already. So it's like this line right here. And that line has the equation x equals -1. And again, you can always just call it x equals h, which turns out to be -1, right there. But know that it's like the vertical line that goes through x equals -1 is x equals -1. So to find y-intercepts, you set x equal to 0. Those tend to be a little easier to find. So I got 2x plus 1 squared minus 6. And so I set x equal to 0, and I get y. 2 times 0 plus 1. Actually, I can see it right there. It's -4, but I'll just do it this way. 0, I already did this in calculation. This is 2 times 1, which is 2 minus 6, so it's -4. So y-intercept is 0, -4. To find the x-intercepts, I set y equal to 0. Again, that's kind of what I was writing here. To find the y-intercepts, set x equal to 0. That's what I did right here. To find x-intercept, set y equal to 0. And again, there was one y-intercept which I expected, and I just don't know at this point. Well, actually, I can look at the picture and tell. There are 2 x-intercepts. There ought to be. If I don't get 2, I did something wrong. So right here it says find x-intercepts. 2x plus 1 squared minus 6. That's y, right? I do that right? Yeah. You set y equal to 0, which means 0 equals 2x plus 1 squared minus 6. You could like FOIL this and then try and factor or something, but I'm not going to do that. I'm going to add 6 to both sides. You get 2x plus 1 squared equals 6. Divide both sides by 3. Plus 1, sorry, divide both sides by 2. X plus 1 squared equals 3. Take the square root of both sides. This is the dividing by 2 step. This is the square root step. I get x plus 1 equals plus or minus root 3. I'm going to subtract 1 from both sides, and I get x equals -1 plus or minus root 3. And that's what these two numbers are. -1 plus or minus the square root of 3. No, you're never going to be able to guess that just by looking at the graph. So we do some algebra. And this, of course, is 2 answers. It's -1 plus root 3 and -1 minus root 3. The last 2 things we'll say today are, does this graph have a maximum or minimum value? And what that means is, like, is there a bottom to it or is there a top to it? And if you look at this graph, there's clearly a bottom right here, but there's no top. These arrows tell you that the graph goes on forever in the vertical direction, in the positive vertical direction, but it stops here. So I would call this value a minimum value. So when I ask this question, I'm asking about y's. Y value. Does it have a maximum y value or a minimum y value? And the answer is it has a minimum value. Because there's like the smallest y that occurs, but there's not a biggest y. The smallest y is -6. And what is the range? Y'all remember range from the first semester. A range is all the y values that you get for this function. You can see what we just did, that the smallest one is -6, and the biggest one is, well, there is no biggest one, so we say infinity. So we say like this. This would be the range. Or you could say y is greater than or equal to -6. Either one of these is, in my opinion, a fine way to state range. So we'll talk a little bit about these two, maybe in class. There's like kind of a specific way to do them. I don't know why I do them in this video. So look forward to seeing you guys then. Bye.